Now here we're going to switch over and we're going to do integration by substitution. So the key steps using these formulas 1 and 2 and 3 is recognizing the formula or the form of the integrand. Some people actually find it difficult to identify your f and f prime in these formulas, what we did before in those general ones, and they actually prefer to use substitution to simplify the integrand. So the method of substitution, which we're going to discuss now, becomes increasingly useful as we progress through our studies here in integration. And so what we're going to do is we're going to recall the definition of the differential and represent the derivative. Again, that was the dy dx, if it's going to write, taken as a whole, and now define dy and dx as two separate quantities with the properties of the ratio still equal to the derivative. So if we have y equals f of x, and that defines our differentiable function, then the differential d of x is the independent variable, x is the arbitrary real number, and the differential dy of the independent variable y is defined as the product of the derivative and dx. So dy is the derivative of f of x times dx. And so sometimes you'll see dy dx equals f prime of x, and all we're doing is we're multiplying both sides by dx, and so we get dy equals f prime of x dx. All right, so what they want us to do is find dy for those functions. So for a, what do we have? Well, we have y equals x cubed. So the derivative of y is equal to what? Well, that's going to be, take that derivative, 3x squared, and then dx. So we have to take the derivative of both sides, and so that's why we have this dx over here. What about b? Well, here instead of x's, we're going to use u's. So we'll say u is equal to the ln of 2 plus x squared. And so du is equal to, now remember, it's going to be this thing over 1 over that, 2 plus x squared, times the derivative of the inside function, which is 2x. And then we also have dx. And if we want to, we can say, well, that's 2x dx over 2 plus x squared. We can put the dx out here. It kind of all depends on how you want to look at it, because this is also 2x over 2 plus x squared dx. So all those kind of represent the same thing. All right, what about c? Okay, now we're in terms of v instead of u or y. So the only thing difference, so I'm going to say, well, v is equal to e to the minus 5t. All right. Well, we want to find dv. So that's going to be what? Well, now we're going to take this, the derivative of this is going to be e to the minus 5t times the derivative of the inside function, which is going to be a minus 5, and then times dt. And if we put that all together, that's a minus 5 e to the minus 5t dt. Okay. So that's how we're going to do finding derivatives with pieces on each side, where I have the dy on one side, dx on the other, du, dx, or dv, dt. So all depends on what we're looking at there. All right, let's stop there and come back for more.